These images were captured after two deadly earthquakes in Turkey. They resulted in widespread damages, killing thousands of people. The catastrophic quakes were also felt by nearby countries. Space-based satellites provide the most accurate weather predictions. They also warn us against impending storms. But is it possible to make a space-based prediction for an incoming earthquake? This is Spaces. Before jumping into it, let's look at what space contributes to disaster management and how satellites are revolutionizing earthquake relief efforts. Space technologies play a vital role in disaster management by providing timely, unbiased, and accurate data. In this way, risk assessment, preparedness, and response are enabled. Known as Europe's Eyes on Earth, the Copernicus Emergency Management Services is one of the response systems, providing detailed information for selected emergency situations that arise from natural or man-made disasters anywhere in the world. Satellites help respond to and recover from earthquakes. Here's how. With high-resolution imaging capabilities, satellites produce detailed maps of devastated areas to detect the extent of damaged buildings and infrastructure. A quake comes with its aftershocks. Satellites detect changes on Earth's surface to assess the risk of aftershocks. Reaching affected areas quickly for aid workers is crucial. Space-based tools enable communication and navigation services, contributing to relief efforts and monitoring the environmental impact of earthquakes such as land and water use is also doable thanks to satellites. The most important question is about the probability to predict earthquakes from space. As we already know, satellites can detect changes on our planet's surface. These changes may be a sign of an impending tremor. But earthquakes cannot directly be predicted. In 2002, the magnitude 7.9 Denali earthquake cracked highways in Alaska. The European Space Agency confirmed that the quake set the sky shaking as well as the land. There are several different types of seismic waves moving the ground during an earthquake. The largest scale and the one that does most of the movement is known as a Rayleigh wave. This type of wave rolls along the ground up and down and side to side. Previous research has established that shock waves from Rayleigh set up large-scale disturbances in the ionosphere. Interferometric synthetic aperture radar and global navigation satellite systems are satellite-based techniques. They can detect alterations in ground deformation and detect the subtle movements of the Earth's surface before, during, and after an earthquake. These changes help scientists and seismologists understand the hidden causes of earthquakes. However, the changes in question are not reliable sources enough to predict the exact timing or location of an earthquake. The reason is that an earthquake is caused by complicated interactions between tectonic plates underground.